So, hello everyone. I believe uh, we are live, we are global with one of the other installments on potentials of e-commerce that actually is the uh, eighth one in the series. And this is also the second one that we are talking about ChatGPT or generally GPT, Palm, and other type of large language models. In general and in particular for e-commerce. And we have Nishan with us, and we talk about it about several interesting things about it. But I think let's and please feel free to ask if you have any questions or comments. You can ask at YouTube in particular or LinkedIn. These are the places that you can ask, and we'll be happy to answer. You can just put the comments. I will also check some others like Instagram, but these two probably would be the best. But we are live and global on Facebook, Twitter, YouTube, and LinkedIn. Okay, so I think without further delay, let's talk with Nishan. Do you want to just maybe give some recap of the things that we discussed previous time, and then we can go to new stuff?
Yeah, thank you. Good morning, evening, afternoon, everyone. Thank you again for joining us for another session of Monetization Monthly. We're continuing our conversation on large language models, generative AI, and how kind of it's captured the world by storm recently. In our last installment, ChatGPT had just come out. Microsoft had just very recently announced their interest and kind of stake into it, and Google was nowhere in the picture. Since then, a lot has happened. GPT-4 has come out, and people have interacted with that for a few weeks now. Google has just kind of recently announced Palm 2 as well, which is their response to GPT-4 and provides a lot of similar capabilities in addition to kind of extended tokens. We had barely just started talking about what LLMs are, common forms in regards to how they're trained, and what this could potentially mean for e-commerce. Now we get to dive in a lot deeper into the different areas that these models have made progress in so far. So thank you again. Excited for this conversation.
Yes, thanks for the actually summary. So I think let's start. A little bit about the LLMs. So I think if we put it, so this kind of language models, they have existed essentially before, and generally these are some kinds of things that there are probabilistic methods that token by token they try to generate a sentence, and of course that sentence can be a paragraph or maybe a text essentially. And I think the novelty that happened somehow in ChatGPT, maybe the models were there, and this kind of language model, the people consider it for years, I think. But the issue, I think the miracle happened in a sense that these sentences, now you can actually, by token, you can generate a full sentence that has a meaning. And also, you can put several of these sentences together and they form a text. And in addition, I think the prompt engineering. The prompt, I think that is another thing that's somehow perpendicular to this, or maybe, not completely perpendicular, but it's a different aspect that the people can ask. And this, when you say something, that actually can understand and do some additional text operation on the text that you are giving. I think that's also another amazing thing. Lots of writers, lawyers, I don't know, doctors and others, if you want to write something, you can just use this one essentially to improve your own text essentially. And somehow the idea of this is that, you can think about that, like you are writing a sentence yourself, but you may not use the best word. But in ChatGPT, in some sense, it is like some Google search engine that it goes through all, these are like, it is generally trained on the all data in the internet, this like text and websites, etc. And then it learns essentially that what is the best sentence or what is the best words that you can use it. So sometimes you will give some word to that and actually it can rewrite it in a much better way because it optimizes essentially not on my knowledge, say, by the knowledge of the whole world in some sense and the best sentences that exist there. So the quality of this actually becomes much better and much smoother. So that's somehow the LLMs. And I think the idea here is that, of course, the whole idea is that here we are talking about a text. And this kind of, and I think we discussed previous time, these are somehow generalization of word to vec type of things that was there. So that we are, this is, I mean, some of this skipgram or others essentially that was there to generate the next word or finding similar word. But these are the next levels of them. But the good thing, I mean, the same thing that we talk also about the word to vec, that currently this kind of embedding is used for almost everything. Graph to vec, product to vec. I mean, that's the thing that we use in a lot of e-commerce and retailers. I don't know, node to vec and lots of other things that everything will be essentially vectorized and embedded. So the same thing now happening with LLM. So far we talk about the text. And again, word to vec was essentially the original thing was to embed the words essentially for this kind of natural language models or like a NLP stuff. Now, and after that, it has been essentially used for lots of other applications. That anything that you can embed it, like product, like items in a company, or anything essentially else. But the same thing now is happening for LLMs. Now, first we are starting with some text, which is already very useful, and this kind of nice text that we can generate. But the question is that this is not only this. You can think about programs. Of course, some of them are ChatGPT is already doing that. Some actions, I mean, or some queries. I think we will talk about it in particular about AutoGPT and LangChain that we can briefly discuss them. These are some new popular open source things that we are talking about them. So this is the idea that how much we can use that and for other applications. And then, I mean, near the end, I will actually talk about some more philosophical things, essentially, some of these letters that, for example, written by, I mean, at least signed by lots of people famous in AI that we should delay for 6 months, and then Jeff Hinton's letter. And there are some other things that we will discuss about actually sleep dreams and other things, some other works that I'm doing actually on that one. These are actually interesting things, philosophical, so for everyone to think about it. Good. So do you want to add anything?
Yeah, I think maybe like the kind of structure we can approach this conversation with is like, let's maybe dive in a little bit into what's happened in the recent improvements, particularly around prompting and kind of these open source libraries you mentioned. Let's also kind of take a little bit of a dive into retail and what's happening there. It's a very interesting Wendy's partnership with Google that's been announced recently. And then we can get into the more philosophical topics. So,
yes, I think the philosophical would be for the end. I think that we can, stay tuned essential for this one. But also, I think we want to talk a little bit about this kind of the training, fine tuning versus multimodal, like multimodal fine tuning versus prompt engineering, etc. I think,
Yeah, so
you want to start with that? Maybe I think we can talk a little bit more technical and LLMs that I give some introduction for that. Then we will go for the other more technology, and then at the end for philosophy.
Sounds good. So I think the thing I've seen recently is there's been so previously, like our last conversation, what we were seeing is people were discovering a lot of the possibilities of just prompting these language models and getting reasonable enough responses. Now that people have had a chance to dive in a little bit deeper, what we've seen is the prompt itself makes a huge difference in terms of the output that you get from these models. And so I think this is probably the fastest rising job industry, at least in tech, is prompt engineering, right? Your expertise in terms of how you're defining these prompts that go into language models make a huge difference in regards to the output that you get. So in that regard, a big piece has been, and actually so that's one end of the spectrum, going from, doing nothing like a 0-shot prompt to getting better at the prompt itself, but still being zero shot. And they're finding ways to create a multi-shot within the prompt itself. You were going to say something on this?
Yeah. So I think, I mean, prompt generally, it means that the question that we are asking from this ChatGPT or other things, or Bard, or I don't know, Bing and other stuff. And this is the thing that we are answering. And I think the main challenge here is that somehow this model should understand what I'm talking about and try to do some actions on that. And that's the meaning of the prompt engineering, essentially, is that like better, like understand better, essentially, the question that the people ask and can take actions on them.
Right.
Is this a correct definition?
Thank you. Yeah, it's essentially the input you provide, the query you provide to the language model to get the response that you're looking for, right? So to me, there's like a spectrum of how much effort you undertake in terms of getting these language models to provide what you're looking for, right? So on the other end of the spectrum is your maybe you're training these models from scratch. So that's very high effort, very unlikely that unless you're a really large institution heavily involved in this area, that you would go all the way to building a new set of model. So the next set of things that people have been doing is fine tuning on top of these existing models. Now, there've been APIs available with OpenAI itself. Google provides these capabilities as well. Lots of research out there in terms of how you can fine tune on top of these existing models. But even that has been challenging from a performance perspective. We've seen the most effective models right now are, like over billions of parameters in terms of size. So even being able to find the compute resources and memory resources to load these models up and perform those computations are quite challenging. So
this is the one that we call it fine tuning, essentially.
Exactly.
So maybe this is I think we have the original training as I think like 4 trillion data or something like this, some range like this, that you need to train this one, I think, by some kind of, I think, like 7 pages. These are like the epoch. I mean, this is the size that they are giving, and they are essentially training this data. That's a huge one. I think that needs a lot of money. Then it is the fine tuning that somebody has trained this one. Can we do more on that and get essentially some, maybe optimize a little bit parameters? That's essentially the fine tuning. And I think the last but not least one is the one that these are the questions that the people ask and you want to understand and answer based on that. That would be the prompt engineering.
Exactly. And so like one thing that's been very recent, interesting recently is like there's been a number of approaches that kind of reduce the performance characteristics that are required for you to be able to fine tune on these models. So like 2 things, I think that are really attractive currently is one is few shot learning within the prompt itself. So in the prompt, you can teach the language model to behave a certain way. You can kind of provide examples of what you're looking for, and then ask a prompt based on that. A common example of this is like doing math. So these language models have been fairly poor in terms of doing mathematical responses. But one of the bigger advancements that came about is like giving it an example of reasoning itself. Like if you wanted to calculate a simple example, how many apples do I have, right? If Dr. Mohammed gives me 5 apples, I already have 10 apples. How many do I get? If you help the language model with an example of the calculation itself before asking the query, you get a huge lift in performance. So that kind of brings us, like we don't need to necessarily touch the model, but it still allows us to customize it for our needs. On the other side,
if I want to add to this one, so this is some kind of, we can say that some kind of inductive learning that you are giving example by example such that it learns. And you can think about this one. This is also interesting because you have some language models. So some of this has been trained essentially for the all words, say for some all text, but you may want to do for some all programs that exist in the world, and you want to somehow fine tuning for your own application, for your own codes. So in some sense that you can think about that way, that you will download some of these models, maybe you don't change it, but you want to give more of your type of questions that you have it in your company and train it based on this one, such that I think this is the same thing that you mentioned, this LLMs behave the way that you want, more
Exactly.
based on the data that you have. So in some sense, this is the data that we will try to put it. And this, you don't need to change the original models, and that's very costly actually. But how can we do it through prompts essentially and change it a slightly much cheaper way and still get the result that we want?
Exactly. So now if we get a little bit more sophisticated than just that, we're finding that like, how do you augment these language models with your internal source of data? Oftentimes, like for examples where it may not be practical for you to kind of retrain these models, you can still set up a retrieval task as part of your chain of prompts. What do I mean by that, right? So if let's say you have an agent AI that you want interacting with a human. So based on its interaction with the human, you might get a set of paragraphs, like language context, that you can use within your internal retrieval systems, get back the set of responses from that, and then use that to then provide few shot prompting for your query then onto your language model, so that you can provide it with more information and ask it to further process it, right?
Yeah, so I think, let me say my understanding on this one. So in some sense, you can say that, I mean, this is the LLMs that are there. You cannot, I mean, change the training, etc. It is somehow written in stone. It's very expensive. Yeah. Now the question is that, I mean, I think this is somehow the way, again, to the same thing that we have. You have your own data. Say maybe you want to write some text, essentially, some book, something like. You are adding the text there. So the question is that, I mean, this text, and you are making some queries based on that. The question is that, I mean, you may want to essentially learn from these queries, etc. Somehow this is, I want to say this is maybe the second language. The first one is the LLM language that you have. And this is some language that you interact, some kind of prompt that you are talking about it. This is somehow the second language. You want to have some kind of compiler that when somebody asks question, change it essentially to the prompt that this LLM understands better, and essentially ask LLM to provide this input plus the data that you have it, and you give you essentially the best things to the user.
Exactly.
Am I right?
Yeah, exactly. And even amongst this, right, there could be multiple different ways you integrate your internal retrieval or like search engines with the LLMs, right? Like you can imagine creating multiple like subtasks that maybe the LLM is better suited for, or like making the LLM find appropriate suitable queries that feed into your retrieval system, or maybe leverage the information there better to get its output. So an example, like LangChain is a publicly available open source library that allows you to compose multiple of these prompts together. So it's gained a lot of popularity recently, and people are using it to kind of compose multiple of these kinds of queries together. So very, very exciting from that perspective. Now, if that still doesn't kind of satisfy your needs, and you want to train on your specific data, but you don't have the resources needed to train these large set of models, there's also been very interesting research in a general area that's being called LoRA, which is low rank adaptation of large language models. So essentially, this is a training method that accelerates the training of these models with consuming less memory. So what it essentially does is like it preserves the weights of the models as it stands, adds a few like much smaller set of new weights and trains those weights. And that's found to provide very promising results as well. So, the previous trained kind of weights are frozen. The rank decomposition matrices that are introduced, which is essentially the update matrices you're creating, they have significantly fewer parameters, and they're added to the specific attention layers in the original model. So essentially, at each layer of the stack, you're just adding a few variables that you can then fine tune. And what this research shows is that two things. One is like these models are providing really interesting, very, very promising results to the order of like they're coming close to fine tuning. And two, they're able to be trained on very commercially available consumer GPUs versus like previously fine tuning would require multiple like large GPUs. And so you can use some off the shelf, like one single GPU to be able to do LoRa based approaches. So I think this is just the tip of the iceberg. Like this approach is going to see rapid development in the coming months.
Great. So I think I think maybe it is good for the people. So I think the current one, the one particular open source language model, I think this is the one that leaked from Facebook. Correct? That's the Llama, if I remember the name.
Llama.
Correctly.
Yeah.
So Llama is this is the one that you can use it, and I think lots of people are using that. As far as I know, for this one.
Yeah, there's been like very interesting approaches on this as well. So from Llama, the new, I would say, kind of standard is called Vicuña. Vicuña is essentially, there's lots of kind of like jargon I'll throw around. Vicuña is an open source chatbot trained on fine-tuning Llama based on data collected from shared GPT. So shared GPT is this open source like a like Chrome extension essentially that allows you to interact with ChatGPT, and people are using kind of the responses from there to train a chatbot based model on top of Llama called Vicuña. And that's showing pretty good performance when you compare it to ChatGPT.
Is this the one that I think came from Stanford? I believe there was one for the prompt part that was coming.
Yeah, actually, that's right. Yeah, this comes from, so the team for Vicuña comes from UC Berkeley, CMU Stanford, and UC San Diego.
Great. So that's essentially something that, this is comparable to that. And I think this other model that the people, I think you mentioned, this is like, I think this is another way that these people are thinking, the way that you mentioned for training. So in some sense, you can consider some hyperparameter. So there are like this large number of essentially parameters that are there, but you may not be able to individually essentially change them, but you may consider group them into some essentially small things, and then you will put some weights for them. And these are the new parameters that you are adding it. And as you mentioned, actually, the people can add this parameter. These are some kind of coefficients of those already parameters there. And still, this is some kind of, I will say, hierarchical things you can consider. Lots of parameters that here, but we can have some hierarchies of these parameters. And then for each of them, I'm putting weights essentially without really any need to change the original things. But I can do that one, and whenever I need, I just add this multiplier to the number that I want, and essentially
exactly. The beauty here is like these are being appended on each of the different layers. So you are still getting that like meta level of fine-tuning capabilities. Like one of the early things we saw with image deep learning models is like the higher up, the more abstract the layers get, the more abstract the concepts that they capture is. So with the same analogy here, right? Like even with introducing very small set of parameters, you're still getting them from the lowest level of detail to the most abstract forms of detail within your larger kind of like LLM context. So yeah, it seems like that's sufficient to capture a lot of kind of domain specific information that you want to use.
Yeah, so I think in that sense, actually, is a very, a nice thing. So I remember actually the time that Google, I had this kind of deep learning. Essentially, they had this idea that actually we can essentially train the model on a very large data. But at the end, the model would be so small that I can deploy it essentially on your cell phone, and you can just run it. Your cell phone does not need to have that big information. Just this model is somehow, this kind of embedding essentially, or a sketch, you will call it, that is enough that I can compute the things that you want essentially and give a good result.
Exactly.
So in some sense, we are doing the same thing essentially. So here, maybe the number of the hierarchy become a bit one more level essentially. We have the huge data that we have it. there are some of these companies, big companies that like Google or like OpenAI or Microsoft, they are actually training on those data. That's a huge thing. And then we get some parameters there, and it might be not optimized. I can't say, give a good example, probably BART, essentially one of the things that is working on, I think, Palm 1, maybe now Palm 2 is better, essentially, but it was not the best things. But anyhow, it has been trained. And the issue is that this big data, still it is big, even though it's not the original thing, but the number of parameters is big and it's still expensive. Now can we to have one more model essentially on that? And this one more model essentially puts some kind of hyperparameter or super parameters that control some part of this, and we still get a better things. And again, everything we try to, I want to do it on my own computer. So I don't want to go all there and pay this expensive thing. And then even you go one more things, and even like about this prompt part, maybe even at the prompt part, even if you need to change something, make it more specific for your own data, your own language, your own queries, that also you can maybe do it on just the prompt part without even changing the other one. So at multi-layers, the people try to don't pay that much cost of computing while they are improving essentially this for their own needs.
Exactly. Like the I remember like the last time we talked about LLMs, like cost was a huge concern. And this quickly we're seeing like, very, very effective approaches to kind of cutting down on cost. Another kind of axis I wanted to also briefly mention here is like, so Meta has released interesting paper on image bind, which is they're capturing multi-modalities in their kind of large generative model. So image bind takes in textual, audio, depth, heat, and infrared information onto their models. But there's like multiple different, like video is another really good example, but essentially combining these different kinds of modalities into one model, I think is another frontier that's going to see a lot of traction in the coming few months. For like image bind, they call it like one embedding to bind them all. So this is mostly coming from like the VR, AR experience needs, but some really interesting things that are coming here is like with zero-shot learning on few-shot recognition, these models are performing better than state-of-the-art models trained for those specific tasks themselves. So just adding multiple modalities of information makes you perform even a single modality task better. So said differently, right? Like by adding images to your language models as a source of input, you can improve on a language task itself. You can, you can perform better on a classification task, like a token classification task, better by adding images to your training data without even needing to kind of do much with the image itself. So like another kind of really fascinating like development, I think, in this space.
Yeah, I think that's actually beautiful. So that's the thing I want to give this multimodality. I think a good example would be like this, that you want to essentially create a movie and you have some kind of text that some story that is written essentially as a text essentially. So you want to read this one and see, all the images that you have it, all the part of the movie that was existing in the past, you may, and all the images, say, you want to combine all of them into a new movie essentially. And in some sense, the whole idea that is kind of tokens that we were talking about it. So token can be a word, but at the same time, the token can be also an image. It can be part of a movie. And this one, you can put them together and then I think bind them in some sense to, like, when you put some text and some image, probably this person should talk about that particular text. So in that sense, we can bind this one and get much better or nicer things. And as you mentioned, I think that is interesting because in some sense it is like a leaking of information, because we don't we know that some information from these images or some of these movies or the text, they leak into each other. So it is exactly, these are the things that these kind of complicated models, optimizations are doing. You get a better optimized model in some sense because you have more data to train in some sense.
Exactly. Yeah, and I think that takes us to the other thing I wanted to mention was around auto GPT, right? So essentially what we talked about so far is like, these models are getting faster, they're getting better, they're getting more like useful for specific tasks, and with multimodalities they can consume multiple different kinds of information, which makes them extremely capable to be able to interact in the human world in a much more native form. And so like auto GPT is one of these kind of efforts. This is an open source like project again, and I'll just kind of read out the description that they have. Auto GPT is an experimental open source application showcasing the capabilities of GPT-4 language model. So this program, driven by GPT-4, chains together LLM thoughts to autonomously achieve whatever goal you set. So essentially, this kind of like, this is, I think, philosophically trying to push the boundary from like what these models are capable. So like you can assign it the highest order of tasks. For example, I want to go on a fun vacation with my family without, give me the itinerary, right? So it has the capability, or you can structure it in a way where, the first prompt you ask GPT might be like, okay, what are the steps I need to take, right? I need to book airline ticket, I need to book hotel reservations, blah, blah, blah. So break it out down into multiple tasks. And once these tasks get specific enough, Auto GPT introduces plugins that allow you to execute in the environment based on these. So one example with this travel booking thing might look like, the first step is like, okay, book an airline ticket. Maybe it calls out to the Google Flights or, particular airlines API to make a reservation on your behalf based on this itinerary that it set. Second, it may then send out a calendar invite on your calendar so that you're aware of this. It might then book the hotel. And as you can imagine, as more of these integrations kind of exist on the platform, they start interacting more natively with the environment.
Great. So I think these are, some of these things that we have this new technology since the last time that we talked about the image bind essentially by Facebook. And this, I think this LangChain that is essentially understand better the queries, essentially this kind of translator to better language or language that LLMs can understand, possibly get some feedback from LLMs, because these LLMs are a smart thing. These are not just some kind of it's not just some kind of dumb thing. They can also help you to even have a better query things. And I think the last but not least, this Auto GPT. And that's actually another, that's a very interesting thing. I want to add a little bit more to Auto GPT, but I think another one that actually I think is a new one about this vending launch. I think that is especially has some applications for retail that we are talking about, essentially e-commerce and retail. I think we want to talk a little bit about this vending launch. Then I want to add something for Auto GPT, which is related to other things that we are talking.
Yeah, absolutely. So now switching kind of to more retail centric conversation, right? Wendy's just announced order taker AI chatbot in collaboration with Google. So essentially the idea is you drive up to a Wendy's just like you would in a drive-through, but instead of interacting with a human that's taking your order, you can now interact with an AI that's able to take your order and process it. They just announced this in partnership with Google. I don't know which exact stalls you can find them at, but this seems like a very, very kind of like specific poignant application in the retail space of these LLMs. Any thoughts on this?
Yeah, I think in some sense, I mean, I was actually needed to call LG for a washer. They have the same thing. They say, oh, I'm a smart essentially bot. You can talk to me. In some sense, this kind of thing exists, but nowadays maybe the people try to bypass them. But this company, as these comes become more smarter, essentially, they are forcing you to talk with these guys. I think that's probably the trend because they were this kind of thing. They didn't quite understand you. I think maybe there is still, I mean, some of this. I mean, they about the understanding the language or accent that might be there, but you may force actually as these things become better. I think probably the main problem is the accent part, or the still I think maybe these are not perfect in understanding what I'm talking about. But like even at Google, for example, we talk in YouTube and we put essentially some of these captions, but the captions are not exactly the thing that we are saying. Like in terms of accent, I think this is probably the most important barrier because as long as if they can resolve this issue, then the rest of it essentially can be done by these things like something like ChatGPT and others. They can handle it very well. I think the main part here is the bottleneck actually is this understanding the accent and the way that we are talking. But after that, as you mentioned, so this is the one that they can do it. And probably more and more they are improving on this part, understanding people better, and go more and more towards this way that you are just talking with the bots essentially, no human things, and that they are essentially removing jobs. Is there anything else? I mean, I think when they launch in some sense that they are working with Google, they make it maybe more prominent in that sense, but at the same time, the same story that lots of other things are using, and probably they will essentially shift more toward this talking with bots instead of humans.
Yeah, I think a few different threads I want to pull on here. First one is like I think yeah. So a quote from like Wendy's CIO is like he mentions that this bot is at least as good as their best customer service representative, and it's probably on average better. So my interpretation is like this bot interacts better than the average customer service representative at Wendy's. So and yeah, previously kind of you'd mentioned like always wanting to get to the agent, because like over years and years and years we've had to kind of deal with really painful menus of interaction, which just end up as being kind of gates and barriers before you can actually accomplish like what you want when you're calling a specific business, right? But these language models allow you to kind of bypass that and have a much richer conversation with an AI, which hopefully translates to the specific action that you need to take itself. And like one, if you broaden that out, right, like one direction we're potentially headed to is like like language models or like English language or like whatever your native language being the interface for multiple kinds of things, right? So if AI is able to kind of hold this conversation with you, figure out like what you want to order and take that order, and as we mentioned before, like if it's able to take an action on your behalf based on that interaction, like there's lots of different kinds of actions that they can take. We've seen like a lot of progress on code generation capabilities of these models as well. So, soon maybe like it'll suffice for us to just describe the kinds of things we want to achieve in a broad set of like human language itself, and AIs take on the load of that interpretation, going from the broad specific like language to a very specific set of coded information for the action they need to take.
Great, and I think we will see more and more of these things. So I think that's actually it is interesting thing. So if you consider this NLPs, I will say that's actually mother of lots of advancement on AI. Because even if you think about the deep nets, the people knew about the deep nets, but one of the most advanced things was this kind of NLP that they showed that actually with deep nets you can get much better results. I think that was around 2008 or 2010 or something like this. And that was the case. Then it comes to this word to vec. Again, we had it starting with this word that you can this paper essentially from Google that shows that actually you can embed the word and get very meaningful information. And now we are talking about LLMs. And in all of this, first it was NLP essentially, then it comes the other applications. like and like deep net for everything, this word to vec, product to vec, and essentially everything to vec. And the last one is LLMs. And I think that somehow the concept of all of them is this one. It is somehow this kind of, we had this kind of feature engineering in ML that we try to find the features. And it is hard to, what are the important features? All of this, they try to essentially get this data, embed it into some space, and then put some weights. And these are this kind of, the dimensions become the important, they all have their own weights, and that these are somehow the features that we couldn't understand it well, but the computer can put all of this and do lots of computation to find what are these information. So in some sense, at the end is some kind of embedding. But of course, once we have this embedding is computed by some companies or us, which is very expensive, then the question that what else we can do it, and this embedding, it can be done for everything. Now I want to go actually to this auto GPT and essentially this question. So as you mentioned, auto GPT is a very good one because now it can take actions. And it can just do, for example, if you want to go to some travel, actually can do all of this. I want to go there, it books the ticket, finds the cheapest price ticket for you. You may talk even with your my calendar, my wife's calendar as well, and send an email if she can just has one maybe meeting there, can cancel that. It can do all of this. And just essentially is a secretary for me that can do and it's a very smart secretary. That, and again, like this is, I think this is the main difference between us and ChatGPT. We might be very smart, but like at the end, this is the data that we have it. But ChatGPT is getting the data over all essentially place in the world, and of course that is like this is the whole concept of much different or much stronger if you get the data over all world, because then you can optimize on lots of other parameters. And I think this is another two things that are coming. One is actually this power of this AI. That I think this is the one that these letters came recently. One I think was several prominent AI people. They were mentioning that okay, we should wait maybe for 6 months for that. I think that was, I don't know how useful this. I mean, they were talking, I don't know, Elon Musk or others. They were signing this, but maybe they are behind the things that they want to just catch up. That was the thing. So I don't know whether 6 months can change anything essentially. But there was other letter, actually, this letter by Jeff Hinton, who got actually a Nobel Prize because of this is like, I think they call it Godfather of AI. I don't know, I mean, like the correct things or not, but he has surely has done a lot essentially to contributed a lot to this deep learning and stuff. And then he mentioned that he actually regretted that he has worked in this area. And he's thinking now the danger, and he resigned from Google such that he can speak up essentially about this. And it was New York Times, all other places. And there are some things that I wanted to mention from this that actually and this comes again to the nice question that everyone asks whether I lose my job or not. So one of the things that we are doing as a human, as I mentioned, we are in some sense, and this is also, it is related to the other thing that I want to say that we are working on some research about sleep dreams, which is actually very related to this as well. So as a human, in some sense, we are doing very similar things that ChatGPT is. But there are some things which are different. You can think also this example, for example, a bird, was flying. And we saw that for a long time. And then maybe, I don't know, 100, 200 years ago that we could fly. And now we are flying actually much faster with much more weight from birds. Exactly the same way that birds are flying, but we got the ideas from them. I think in some sense, ChatGPT is something like this as well. So this is, what does it do? Essentially get the idea of the neural nets the way that we have it, and it's try to train on the data the same way that we are training, but probably the way that our neural nets are a bit different from that. But that doesn't matter, because no one says that the one that we have in our brain is optimal. This may work better because it can optimize, it can use lots of compute things that we don't have actually that in our body. So it is already improvements, even in terms of compute. The other thing is that not only it can do this one, now it can get the data of the whole world and experience of the whole world and optimize on that one, which is much stronger. No human can claim that he's like smarter than the whole world, essentially. And so that's another aspect that actually has been added. I think the third thing is the one that Jeff mentioned, and it is actually very important. One other real barrier for us is that, in some sense, you can see the whole, evolution was something like this. That we started from bacteria, then these are this DNA or genes that we could essentially give the information to the next generation, and then we could essentially speak and we could write, and then we could, through books, we could give it. Now we have essentially computers, then they can get lots of data, and then we have the web, that we have everything it is on the web in some sense, and we have a lot of information. And of course, these are all languages, like the words that we have. Now, this data that we have it, now with this data, now we have the whole world. But one important thing is that copying. So in some sense, we are doing the easiest thing in computer is just to copy paste. This is so, like everything just copy paste. And even nowadays, I think you don't have a special icon for copy paste. You don't need to even Ctrl+C, Ctrl+V or something like that. This is exactly that actually humans or some kind of biological creatures have issues with that, because they cannot be copied easily. So if I have anything like Einstein, can we maybe create several Einstein and they work essentially on different environment and essentially improve the thing? We cannot create this, and that was a big barrier. I think the main thing that he mentioned is that no, we don't have that barrier, because you have this program, you will just, all information you may generate essentially, 10,000 bots. Each of them go to the different environment. They get essentially some information. And just in a less than, nanosecond, all of them have the information on all of them. So that is like very scary in some sense, because now you can learn and you can essentially somehow transfer the knowledge much, much faster than the one that we could do it there. And that's the thing that actually makes the life much, harder for humans. This is like the part that I want to go a little bit more to this kind of philosophical thing. And in particular, for example, you want to say that which job essentially, the ones that will be preserved, which job essentially will go away. One thing is that, okay, maybe the lawyers, the doctors, and others, these are like project managers, for example. Lots of this can be done, like Auto GPT that you mentioned, it can do actually lots of them. You don't maybe need the product manager or like the other type of a program manager or something likes to do that, because ChatGPT can do, this kind of Auto GPT can actually do all of this. One thing that also, this is like the first things, but then the other parts that are coming, they say, I'm working on mathematics, so I'm proving deeper stuff. These are the things that so far they have been essentially not that great in it, as you mentioned. Essentially we try to have some kind of inductive examples for them, such that they learn more and more there. Still, we are not there, but I assume that also they will learn like in the next 10, 20 years, maybe sooner, essentially, this information. The other one that people say, oh, that's the other thing, that maybe I'm safe if I'm a plumber, if I'm an electrician. That's the thing that I'm safe, essentially. And because they cannot do it. In some sense, it is correct, because our progress on the robots probably has not been that much comparing the one that we had it with the other stuff. Because, for example, this fact that, my finger can sense something, we don't have this type of things yet. But again, we should not be that much proud of this, because some of these things, actually, it might be not relevant. So you may think about, I want to do plumbing. So why do you need plumbing? Because you need water, essentially. But the robot does not need any water, essentially. If it needs some kind of energy, it can actually get it directly from the sun. So this is exactly the thing, the bird thing that I have mentioned with this airplane, that we can fly, but we don't need to do exactly the same thing that is doing that. So this plumbing job, it may go away, actually, because there might be, if there are all these kind of robots, maybe we don't need that much plumbing. Even actually the other thing that was very interesting that you mentioned, this image buying. What does it do? You may think about why a plumber essentially can do something that we cannot do. Of course, there's some sensing or something that is important, and some creating something that they can do that. But like they can do stuff. But the issue about the plumbing is that actually this can be much easier because we don't have the data. The data that we have generally are the text data. That's exactly the thing that natural language are generally the first thing to do that. But say, if we have actually some kind of cameras that lots of plumbers in the world, the thing that they are doing, we take all the things essentially, exactly the images of what will happen essentially.
Yep.
Then you just give give this one to this one, it learns what are the steps that it needed to do that.
Yep.
So that would be very similar to this auto GPT, but of course,
Yep.
we need to create some kind of robots that they can do exact operations that is needed, then it can actually do these things. So the first thing is that even if we are doing something with the hand, it makes look complicated, that this is not safe. Maybe first, maybe there is no need to that if the robots essentially become dominant. And the second thing is that even that you can train it. We didn't collect those data. Generally, this is the case. So word to vec came essentially. We didn't have this because the history, again, the language we had it, the text, we could do it. But then the people have done it for product to vec. What they have done is they have just the sequence of the user is coming, clicking on something. They say, oh, this is the data. I have lots of them. Let's train this. Now I can get lots of essentially.
Yeah, exactly.
So that's essentially that the fact that we don't have the data. If we say it is useful, and this is the actions. These actions are, you can just bake it. I mean, anything that a plumber is doing, you can make it to a small actions, small tokens, and you will put after one after the other, and essentially do it very nicely. That. So do you want to add something?
I think like lots of really interesting things, right? Like the gist, and I do agree with this, is like it's to me not obvious what jobs would get replaced or necessarily changed. I think we're just kind of starting to see the start of what that would look like. Like one example is like Chegg's stock price went down drastically because and they provided kind of like a heads up that their upcoming quarters would be softer as well, because lots of students.
Which one?
Chegg is essentially, it provides like educational support, educational help for students. And lots of these students have just been going to language models for this. And so like, that's a very obvious area where, you know, like they will provide efficiencies and maybe less resources are required than, less humans are required than originally did. Similar things we heard from like a legal, paralegal perspective. These are extremely laborious mental activities to collate information in particular ways, and those are the classic examples of what we've seen kind of these language models provide. Now, kind of just quickly going back to Hinton, he actually quit Google because, you know, he's afraid that there are bad actors who could try to use AI for bad things. So I want to kind of end up in this kind of narrative, because like we have human bad actors as well. And like what differentiates an AI bad actor from a human actor? I'd love to kind of talk about that. But before we get there, like one of the other founders of AI, Minsky, right? Like a lot of how he went down the path of building like perceptrons and all that stuff was because he tried to mimic human action when it came to like how to develop these like artificial beings. And his famous experiment was kind of the hand that it can pick up as naturally as a human can. And he found lots of complexities there in terms of being able to do it. But you could argue with like all the advancements now, like maybe that's not as challenging of a task to take anymore. And to your point, like there's a very tight feedback loop available there, right? That's one of the things that makes humans capable, is like we're learning in the context of the environment itself based on the actions we take, and we fine tune ourselves based on the actions. Like if it doesn't work today, like we kind of do it tomorrow, and that process accelerates over time. Our neurons are kind of like fine tuned to taking on specific kinds of actions. Now, I think one of the like potential dangers we run into that I see is like, if there are these core generative models at the heart of everything, the amount of variation that comes out of them is probably fairly limited. And so like all things converge to very similar kinds of actions. And this is something we've seen in e-commerce all the time. Like positional bias is a massive problem for us, you know, and like maybe at this point, the research is like 10 years back, but lots of interesting research in terms of how do you debias things that you showed the customer. Like when a customer buys something, how do you know it's because they intrinsically wanted that specific thing versus you showed it up top. So your platform's value translated to the customer making this choice. And that has implications in e-commerce for, if you chose brand A versus brand B, like the brand A is going to do much better, right? So I think the same kinds of like challenges are going to show up from LLM perspective as well. You mentioned like these models can in nanoseconds learn from each other and gather the context. But like one thing in nature, there are examples of cloning or copy pasting in nature as well, right? Like lots of cell division happens from this cloning process, but selective kinds of generations evolve based on a difference, like the cell. This is, I mean, as far as our kind of science theory tells us, this is the fundamental basis for why male and female are created, to be able to kind of create variation in the gene pool and create variation in the species so that we can kind of learn and evolve towards this better optimal situation. So I think a question there will be like, how do we then create that level of variation with these AIs? And maybe it's like just I don't know if plants, when they produced oxygen, thought what they were creating is this next set of species that are then going to exercise a lot more control over them as a species, right? And maybe the interpretation of what control is fundamentally different as well, and maybe like what satisfies, maybe plants are happy enough to breed regardless of whether they're in a tight like line or just kind of scattered around, right? Like we don't know about those things, but I think like where does this lead us down? Like how many humans will there exist? And maybe like a natural function of this, like we're already seeing kind of population levels decline, or like at least birth rates decline pretty much across all of the developed world. So what does that mean in regards to humans kind of with their position right now in the world, and how does AI is affected? I think it's probably at some point reasonable to believe that like AIs are not going to be strictly controlled by just a specific human's objective. And in fact, us as humans may want to give up certain of this like power to AIs, because we know we can codify these biases in a much better form than we do with human systems. So I think like what that integrated world looks like might be quite different from what we imagine today, and maybe we want to exist in that world as well.
Yeah. So I mean, I want to add a little bit of this. I think a few things that I want to say. It is interesting actually. Say, but the part of it actually. But this actually when become philosophy, then the concept of there are religion, God, etc., and then with our humanity. What's the definition of humanity essentially? So that's interesting. So for example, one of the interesting thing about like I can actually say about the sleep. So there are like the people that believe that essentially in soul, etc., and that essentially now you can say that eternity and other stuff. And one of the issues about the sleep dreams, essentially. So there is a soul actually that can do these things that I'm seeing that, okay, I'm sleeping and I see that, oh, my father who passed away come talking to me, and etc. So that's actually interesting. And then we say, oh, this is my soul actually is going to the maybe next world or something like it. Interestingly, this miracle, I will say, in some sense that happened for ChatGPT can explain this thing. This is like a new paper that we are working on it. Because like, in some sense, like the thing that we are doing in a sleep dream is nothing than the thing that is like this kind of large language models. So in some sense, like you just think about ChatGPT is trying to get the data from all over the world, and then now it can optimize to make very nice sentence, essentially, or nice paragraph. So you can think about it as something like this. When I'm talking now, I have a control about the brain, about the prompts. But when I sleep, I don't have essentially control. There's some prompt maybe by today things, or maybe 10 years before, something prompts essentially. And then there are some actions, exactly the same thing that we talk about this some action, some items, some tokens are happening. And these are exactly, I think this is maybe more toward this kind of image bind that you were talking, that actually some events now happening and some text happening. And then lots of the time, actually, this sleep dream that we are seeing, there's not much meaningful. But once a while, it becomes actually very meaningful because it is exactly the thing that happens essentially in this kind of ChatGPT before. Before we could generate sometimes some languages, some sentences, but lots of the time it was not that good. But now with ChatGPT, more optimized things, now we can generate the things. So in some sense, the sleep that I am doing, a sleep dream that I am seeing is nothing more than the same neural net or this thing that is just, or ChatGPT that just put some events together, sometimes becomes meaningful and I see something, oh, this was real, I saw my father, but this is just essentially putting this one from lots of this, my own past experience, which is much less data compared to ChatGPT. So the chance that it becomes meaningful is less essentially, but sometimes it becomes meaningful. And so this is like lots of these things happening. Now I want to add actually more to the future of AI. So this is like, if you see this one, so if we just forget about humanity or other things, I don't say that we should do that, but I just want to say that you may think about the whole world is this. So I am here essentially, I'm a human. Okay, like in some sense, I am a machine essentially that has been built with certain materials, maybe more water, a little bit iron or other type of metals than others. A robot, a typical thing that we have with more metals in it or more, I don't know, cobalt or others for batteries, etc. Now, interestingly, this would be so the question is that what would be the next generation? And one thing is that, I mean, once a while, after some time, because nowadays, well, first was in language models, then now it is in everything, like Auto GPT and others. Now, at some point, these computers become smarter than us. And to compete with them, I think that was also, I think Elon Musk probably mentioned that, I mean, I can think at some point that there are some chip should come in our mind essentially that helps us essentially to work with these things and optimize these things. And by the way, this is not very scary because already it is there. So there are like, now they are doing operations. For example, if like the people becomes old, they have a knee problem, they will take all the knees out and they will put metal there. So it is already somehow the combination of me and metal is already there. No, it is just a little bit of me. So I think that would be something that I can imagine that for a while, I mean, that would be the combination of like humans, especially because of these sensations and others that there is still not in robots. A combination of that actually can proceed for a while. But at some point, they may be replaced, essentially. Some of them, it might be needed, and it might be not needed. And if you think that I'm a machine, the bacteria was a machine, and there were, I mean, lots of other animals, they were machines, like dinosaurs, and they are not there anymore. It might be some creatures, which is a combination of us and these robots, and it has certain material. That's the one that actually going next time, going essentially continues and evolve. And as you mentioned, I think one of these things that you mentioned, that is the danger that, I mean, if everything is copied, this is, I think, the danger that everything is like that. But this is the same thing that we are doing generally in neural nets. We try to mute some of these things. Randomly, we will change some of this data, and we hope that something good happens. So that can be actually the case that at some point, I mean, then would be a combination of humans. And these are all these movies that we have it there. But this is some interesting thing can happen actually, because now we cannot go, for example, to Mars or and other places. Why? Because we need oxygen. If this robot does not need any oxygen, then if you can just take some of this material, take the energy from the sun, then you will put it in some kind of rocket ship and then send it to the rest of, like, I don't know, far from in the world. They can go and they can produce themselves, because generally then they generally need something, not oxygen is not the main thing for them, but this kind of materials, cobalt, metal stuff, and this is almost everywhere. So they can go and create. So in some sense, that you may think about some new form of, I mean, the human or combination of human robot that will form, and they may go, and they are, of course, already there. Like Mars, we have Curiosity or other robots that are going there, but they are not that smart that they can create themselves. But they can create such kind of things, and in some sense, that can be the continuation, because there's a lot of places in the world that you can go, and in some sense, probably this kind of differences would be there. So the people who are living in Mars might be different a little bit from the people who are living essentially in Earth or other places. So in some sense, these are the different countries now that they are doing all over the place. They can essentially talk, and maybe still the communication an issue because we are not that fast to send these robots. So the people who are going much far from us, they may not get the data that fast enough that they can optimize. So
and maybe they evolve themselves, right? They evolve with kind of that environment and context.
That environment, and maybe once in a while they can come back and essentially can copy paste and then go back. So in some sense, this is like, you can think about that. This is, I mean, humanity is just, I mean, you can say the animal. I mean, the animals, they say, I mean, we are the animalities. We don't, we are not talking about them. Some of them essentially not there anymore, but the rest, they are continuing. So in some sense, that is not that scary if you think about that way, that we are just a machine as well, that they can talk, I can think. But yeah, if you put, I mean, more religion stuff, or this thing that, I mean, this is a soul and this is like a God, and then after that you die, it would be another word, that would be hard to justify this. But if you consider this one as, like, yeah, this is the thing that is there, I'm not, this is the same thing that happens to animals, to dinosaurs, happen to humans, or at least some, maybe a stronger type of human robots will continue, but they have this process that they can now go to everywhere and essentially.
Well, even in kind of nature, there is a lot of symbiotic relationships that flourish, right? Like fungi are like good examples of that. Like they work in collaboration. You see, like with lots of like animals as well, you see them like collaborating together to like foster life. And so I don't think it's unreasonable to think that we can come up with that kind of approach with like AI as well.
Yeah, I mean, the viruses, for example, these are like exactly these are the things that they are doing, that they go attack one thing, essentially, they get the whole things. So in some sense, you can say that these are now, and in some sense, viruses are in some sense robots, because they don't have that much brain. At the same time, they're actually very smart things, because they can kill lots of things and no one can, they are very small, no one can see that. And when they go essentially in combination, they can do a lot together.
So with all of this, right, like one question I wanted to ask you is like the biggest like scare that people have here is that of bad actors, right? What makes a bad actor? You know, and it's a very broad definition. And like, what might be a way for us to like limit bad actors in this AI space, and maybe, you know, convert them into good actors?
Yeah, great. So actually, this is the interesting thing. So because, I mean, what is, I mean, the same thing that Jeff also mentioned, that that this is the case. So what will happen? I mean, I can think about some dictators. I mean, and this is like, these people have more power, more money or something. They have this essential ability to hire this kind of robots. And with that, essentially, they can change the mind of the people. This is like the same kind of bad actor that comes in the Facebook or some other things. They can put anything that they think it is right for them. They will put it there, essentially. And the people, they argue for that. These robots are currently very strong. They can argue with an average person. They can even pass some exams, very good scores. So they can actually convince people that it's the best for them. And then they can keep quiet, such that they can get essentially the benefit, those guys. So that's the immediate part that may happen. By the way, this is not something that it will come in the future. First, there are currently such kind of bots all over the place, Twitter and others. More than that, so just think about it when you call, essentially, now I'll compare with 10 years ago. Before, I mean, I could call a bank and say, oh, this is some problem. That's essentially with my bank account or like website. They could actually fix it very easily. Or they could, I mean, give me some credit for something. Nowadays, you will call them. First, you need to pass lots of these kind of bots to talk with the agent. And at the end, the agent says, sorry, I need to do exactly the same thing that you want me to do it. I need to submit it. I cannot manually change anything, manipulate anything. So in some sense, we are already enslaved by this technology and this robot. At this point, maybe some actors essentially contributing that. Again, not even one actor, several of them. Sometimes it might be the bad actor. But the issue is that this bad actor, yes, that might be some kind of transitory time that is like that, but these actors may die themselves as well. And at that time, and also even the action of these guys can be replaced essentially by robots. So this can be some kind of intermediate that some humans, they can essentially, again, this, if you think about the other way that I mentioned, that at the end, maybe there's a combination of robots and humans that they will continue. And anything good from human remains between these robots and they will continue, then you don't feel that much bad. But yeah, in the short term, it might be the case, these people, they try to abuse these things. But that might be for limited time because they will be replaced by robots themselves or the
Yeah,
combination
so
of
I
robots
think
in that sense.
like one theme here, if I try to like generalize, is like if like the actions happen to be in the service of one individual or a select few individuals, then it's generally like bad. Like how we define good is good for the general public, good for kind of maximal benefit in the society. So like I think if we can come up with approaches that allow us to kind of categorically like optimize for the general benefit, maybe that like moves us down the path of like being able to be robust against these bad actors. And like one example of this, I think, can be like I mean, like we know for a fact Twitter and Facebook and these companies already have had massive influences in like big social decisions like elections. Who,
Exactly.
how, like those are like topics of interpretation, but like did they have an impact is like absolutely right, like that's unquestionable. And so as these models are more pervasive and have more capabilities that are more widespread, like that amplifies the risk of exactly like you mentioned, like one actor being able to influence people in a much broader way than was possible before. Previously, like for you to campaign, you have to go to each and every individual location, give a speech there, and maybe it came out in the press, and that's how it got circulated. But these presses were all kind of local and distributed, and then the internet made all of that much easier to kind of have one platform to kind of have your voice propagate through. But like in terms of mitigations, to me, this is why like open source becomes so important, because if just like with blockchain too, like the biggest attraction of blockchain was that the blocks are all kind of public, right? And you have access to, everybody has access to the ledger, everybody can kind of view it, and there are potentially certain protocols that make sure that no entity can kind of control it. Now, we talked about in a previous episode the limitations of that, and how like the evolution of it actually takes blockchain away from those specific goals. But if we think of that from an AI perspective as well, like how might we go about creating these AIs in a way that preserves common good as an optimization objective might be an interesting thing to look at as well.
Yeah, and I think this is the thing. So, like, we know when we talk about evolution, we talk about billions of years that we are here and we are there essentially. And I think if you remember, we talked actually one person at Google, like he was one of these people who was working specifically in this type of thing at Google about this kind of LLMs. I think he mentioned actually that for him having something like ChatGPT, he expected something like 2060 happens, and now we are 2023, and we are
20,
talking about
right.
applications of it.
Right.
So with such a speed that we are going, I think it would be very hard. It might be very short time. I mean, like a short time, again, short comparing to this billions of years that we have been here. That might be a short time that some bad actor they can control the things. But all of this idea of essentially become open source and others, like one person, it would be very hard for one person to try to do that. And the issue that as long as actually this number of people who are controlling our number, they essentially die after some point. It's not that easy that they can get these things. And generally, it is actually hard. Even this is the case that's actually seen very interestingly. Like I see lots of people who are scientists themselves, but their children are not scientists. Lots of this, like you have Einstein, but I mean, we don't have maybe I think one other person from his nephew, one of this from his family was also famous, I think, in some particular area of science, but you don't hear anything. So in some sense, yes, you may get it for something, and the issue is that here you need actually good science, and this is, I think, again, something that you really, I mean, yes, you may get a bad actor, you may get some scientists, but the scientists at the end, if you don't have those science of those scientists, you cannot control because they control you essentially. So in some sense, you need to have the science, to go there. And it is not the case that you may have it, but your son may not have it. And it's not a good scientist. It might be interested in some other thing. So this controlling in the long term would be very hard. And as I mentioned, this is the evolution that should come essentially. Short term, yes, happen. Some countries, yes, it can happen for several years, maybe 30, 40, 100 years may happen for one country. But eventually, essentially, this kind of evolution will go away. And I think that's my current thing that actually would be something like this kind of thing, because that's the thing that gives much more capability, that if some part of me, or like humans in general, is using these robots, that is some kind of survival, because then they can go to everywhere in the world, essentially. The world is so large that there are lots of other opportunities for the people can go and invest on it. And I think these are also, I don't know, I don't want to end it with this thing, sad story, but I think there are current theories that say that, current world is expanding, but at some point falls apart. So yeah, they may go all the time and then falls apart, and I don't know what will happen. Everything will go to nothing. But again, this is like something that, but yeah, I think it is in some sense be scared about it. I don't know whether, yes, you may lose your job and you have there's no money, but I think in the long term, probably the evolution is the one that so far came, this far it came and probably will proceed. It's a very fast speed also.
Yeah, so I think, that's probably like a good place for us to close as well. On the short term, we anticipate a lot of like potential changes because of these models. Over time, it's actually very challenging to like control these things. So they're probably not going to be like the most pessimistic future we think of today. And in the pace of evolution will certainly accelerate.
Yeah, and as you mentioned, I think these are some of these. At least, for a while we can use this one because like maybe a robot does not enjoy that much to go. Essentially, I don't know. Maybe it can actually go to the beach or something like this. But at least now with this kind of auto GPT, these are some kind of secretarial work that actually takes lots of time. One of the things that I try to avoid travel after COVID is like it's a long. It's a very long process.
Effort
you need to do all of this. A lot of time you need to spend, maybe for a few hours, and then all of this can be done by auto GPT or something like this, essentially. So that is much better, essentially. Much like you have very smart assistant who can help you essentially on that. Very good. Feeling essentially, at least for a while. But maybe you don't need that vacation or this. Assistant anymore. Yeah, thanks a lot. I think that was a very nice one. I think we started around some more technical things, some philosophical things. We talked about several things, and of course we talk about e-commerce, about like when this launch or other thing that we talk auto GPT, LangChain, Palm 1, Palm 2, and image binds, etc. Anything else you want to add?
No, I think this is, probably good to close out this specific part. And yeah, I think we should do a few more of these. It's like the landscape is evolving really quickly. So it'll be interesting to log, where we were at with this conversation, and then talk about like what changed in terms of our understanding in the next episode as well.
Yeah, it's because I think like this information that we were talking like two months ago, we had the previous one actually. A lot of things have been changed there essentially. Yeah. And all of these new applications, we expected at that time, but now they become more apparent and they are going very fast speed essentially. So maybe in a month or two again, we will come with a new thing and new potentials essentially for e-commerce and beyond the thing. Thanks everyone for coming to this, the 8th installment of this potentials of e-commerce and retail and beyond. And we were talking this one about ChatGPT, and the previous one also we talked about ChatGPT. And all of these are available at the YouTube and also podcast, everything. If you search, my name, and I think Nishan also put it in his LinkedIn and Twitter as well. So you can watch all of them, and hopefully you will enjoy. Send us any email if we can help you on some of these things that we are working. We will be happy actually to help your business on that one. And yeah, that's it, I think. Thanks everyone.
Enjoy the rest of your day, everyone. All the best.
Yeah. Bye for now.
Thank you.